Hi guys, welcome to lesson 4.1 using graphs to relate to quantities. Our objective for this lesson is that I can represent mathematical relationships using graphs. And the essential understanding is that you can use graphs to visually represent the relationship between two variable quantities as they both change. So problem number 1 is analyzing a graph. The first thing we want to identify is what are the variables in each graph. And then second, we want to describe how they are related at various points on the graph. So for letter A, our two variables are going to be time and length. And what we can see is as time is going on, the length of our board, that's right, we're talking about board length, the length of our board is getting shorter as time goes on. And we notice that this is a sharp decrease. So it's not as if it's kind of wearing down or anything like that. It's just all of a sudden we reach a point in time and the board length goes down. Then it's the same length for a little while, then all of a sudden it drops. And then it's the same length and all of a sudden it drops. So what could possibly be happening on this type of an example? Well, I would say the board is being cut. Right? Because all of a sudden you have a sharp drop. The board has lost some length. Well, how do you quickly remove some length on a piece of wood? You cut it. All right, letter B is the cell phone cost for June. That is our title of our graph. So our two variables are the minutes of the call and the cost of the plan. All right, so we have the cost of the plan and how long the call, how long you are talking on the phone. So we'll notice we have a constant section. Nothing is happening, and then it starts to slowly increase. Well, how can we justify what's happening here? One way to say this would be that there are so many minutes up until this point are included in your plan, and then once you go over that number of minutes, you need to pay per minute. All right, so you're looking at the graph and you're describing what are you seeing on this graph. All right, so why don't you guys give letter A a try. All right, so when I look at letter A, I'm seeing we're talking about the gas in the tank. We have the time in days, and we have the amount of gas in gallons. So as time is going on, the number of gallons are changing. So if we look at this, we have it as constant for a while. Then it's decreasing at different rates. And then all of a sudden it has a sharp increase. Well, what could be happening in a scenario like this? As I look at it, we have it's constant for a little while, so maybe you didn't drive your car, and then you drove it, you used it for a day, and then maybe the next day you didn't drive it as much. Then the next day you drove it a lot more, so the amount of gas went down. Then maybe you didn't drive it as much, drove it a little bit more, and then what happens on this day? Oh look, we put gas in the tank and we are filled back up to our full. All right, so you want to describe the story, describe what you are seeing in this graph. All right, problem number 2. Matching a table in a graph. Oh, didn't delete that. so you can scratch out those directions. That's from your one of your last units. All right. The table shows the amount of sunscreen left in a can based on the number of times it has been used. Which graph could represent the data shown in the table? So we have number of uses, 0, 1, 2, and 3. And we have the amount of sunscreen measured in ounces left in the can, 5, 4.8, 4.6, and 4.4. And we want to figure out which of these three graphs could potentially represent this information. So if I notice my difference from each level of my sunscreens is a decrease of 0.2. Each time we are using 0.2 ounces of sunscreen. Now, as I look at my information, my lowest point here is 4.4. Do either of these two leave me with anything left? No, they both go down to 0. So this would say in my first 4 points, 1, 2, 3, 4, I would get to nearly 0. And we're making a pretty sharp decrease. Is that what we see in our table? No. So B is wrong. In A, it looks like we're going down by pretty similar amounts, but the 4 points that they have listed take us all the way down to 0 amount of sunscreen, 0 ounces. We clearly have more than 0 ounces in our fourth data point, so A is gone. And we see letter B, looks like we have pretty consistent points, and they are decreasing, and we still have some left. So letter C is going to be the graph that matches that data. All right. Letter B. The table shows the total number of customers at a car wash after its grand opening. Which graph could represent the data that's being shown? So we can look at what is our change each time. So from day 1 to day 2, we added 64. From day 2 to day 3, we added 52. And from day 3 to day 4, we added 65. Well, we are adding, our total customers is going up each day, so we can eliminate letters C and D right away because those are showing that we have a decrease in customers as days go on. So as days get larger, our customers should be getting higher. So now let's look at what we have. Our increases are 64, 52, and 65. So 2 of our increases are pretty close to the same, and 1 of them is smaller. In this one, I see a big first jump, smaller second jump, but even smaller third jump. In this one, we have a big first jump, smaller second jump, big third jump, which is what we see in our data. So for letter B, it is going to be graph A. All right, why don't you guys give the bottom problem a try? Letter A. The table shows the total number of downloads from a website. What graph could represent the data that's being shown? So again, let's take a look at our changes from one level to the next. We have an increase of 665, an increase of 244, and an increase of 6,971 downloads. All right, so 2,444. All right, so as we can see, each day that goes by, we are making much bigger gains. So again, this fourth graph over here, which would be letter D, we can eliminate that one because it's decreasing. We can eliminate this first graph because you can see they are going up by regular amounts and we are not. So now we're down to these 2 graphs. They both show that we have a different rate of change from one section to the other. One of them shows that we're making big gains at the beginning and we're kind of slowing down as we go. The other one shows we made small gains and they're getting bigger each time. So the one that represents this, we've got small gain and it's getting bigger each time. The bottom left graph is going to represent that data. All right. Problem number 3, sketching a graph. Imagine someone is on a swing and we want to sketch a graph representing how the height of their waist from the ground might change over time. So first of all, if you are on a swing and we're measuring where your waist is, so your belt line, Are you going to be starting your graph at 0? No, it wouldn't make sense because your butt is not on the ground when you're on the swing. If you are, that swing is broken and you might want to pick a different one. So you're going to start somewhere, we'll just say right here. Now what happens when you sit down on that swing? Well, you got to kick your legs and start to move back and forth. So you're going to maybe see a small rise, and then you'll come back down. Do we go lower than where you started? No, because where you started is at the bottom of that pendulum, which you will learn all about in science in second semester. So we've got a pendulum, so you come back to where you started, and now you're moving backwards. Maybe you're going a little higher, then you come back to where you started, and then you go a little higher. Each time you kick your legs, you're getting a little bit higher, you're getting a bigger height off the ground. Okay? All right, so that would be a potential sketch. Maybe you had somebody pushing you and your increases are bigger than this. Maybe somebody's pushing you and you are starting off and they're doing a very consistent push, so you're always going the same distance back and forth. This is just one potential graph that would represent this information. Okay? So letter B, when Malcolm jogs on a treadmill, he gradually increases his speed until he reaches a certain level. Then he jogs at this level for several minutes. Then he slows down to a stop and stretches. After this, he increases to a speed that is slightly lower than before and jogs at this speed for a short while before slowing to a stop again. What is a possible sketch of his jogging speed during his workout? So our first segment is going to be he gradually increases his speed until he reaches a certain level. So he starts off at 0 and he gradually increases his speed. Okay? Our next segment is he jogs at this level for several minutes. So he's going to have a straight line across. He's not increasing, he's not decreasing, it's a straight line. Next we have he slows to a stop. So he slows down to a stop. And he stretches, so that's going to take a little bit of time. So we have at 0 a bit of a line. Then he increases his speed slightly lower than before, so he climbs back up. So maybe we'll just go up to there. And jogs at this speed for a short while. So he goes straight again, level. And then our last step is going to be slowing to a stop again. All right, so that is a potential graph that represents this scenario. All right, I want you guys to try letter C on your own, even though it's not marked on your own, and then we will go over it. All right, so Mr. Boland and his friends decided to jump out of a perfectly good airplane. The plane took off from the landing site and slowly climbed to 16,000 feet. After Mr. Boland jumped out, he was in a free fall for the first 8,000 feet. Then he opened his parachute and slowly drifted to the ground. What is a possible graph that represents his height above the ground? So we're going to start off on the ground. I get into the airplane and we fly up into the air. Pretty sharp increase. Okay, so that is plane taking off and slowly climbing to 16,000 feet. Next up, we're going to be up there for a few minutes while everybody gets ready to jump out. And then Mr. Boland jumps. Whee! So, free fall, Mr. Boland is falling. He's not, there's no, it's a very fast decrease in his height. Then he pulled his parachute and he slowly drifted to the ground. And there he is, safely on the ground. Yay, Mr. Bullen made it. Okay, so you can see the potential graph. We slowly climbed in the plane. We were there for a moment as I got ready to jump out. When I jumped, I fell, so in a very short amount of time, I decreased a large amount of height, dropped about 8,000 feet in about 2 minutes. And then when the parachute was opened, we drifted the rest of the way down to the ground. So it was a much slower descent. All right. So that is the end of lesson 1 of chapter 4. Make sure you fill out your level of understanding for this lesson. And please make sure you write down any questions or confusions that you may have. And lastly, please make sure that you write down your summary of what you learned during this lesson. Have a great night, and we will see you tomorrow.